Hello everyone, I'm Tamás Roche from BME and this is the Capture Reality module. At this time we'll talk about scan to BIM technologies. So we'll glance through the field to BIM technologies. What is field to BIM? What is the workflow of the scan to BIM technology or applications? And what are the tools we can use to support such workflows? So what are the basics of scan to BIM? First of all, about BIM. BIM is the common model of the AEC industry. We want all the participants working on the same model and see each other's results. So if you want to change anything in an architectural model, you want to see the change in the structural engineering model and so on, and think about the MEP technologies, the building electricity or HVAC systems. You want to check everything one. But all these BIM systems need the geometry. So that's what scan to BIM or field to BIM provides. We often use scan to BIM I think it's the most widely used term for this technology, but I rather prefer to use field to BIM technology because we can provide data not only from scanning. We talked about photogrammetry or remote sensing, so there are multiple ways to reach 3D data from the field to the BIM. So that's why we prefer to use field to BIM technologies. So it's about using field survey in BIM environment, but mostly we are dealing obviously with point cloud based technologies. So in BIM modeling, there are certain requirements. For us, for the geometry, the geometrical data acquisition, one of the most important ones is the LOD, level of development. It combines the level of details in the geometry and level of information. So how detailed we want to capture the geometry? Is it only a block envelope or something about the object only with main surfaces? I want to cover it, or I want to go even in the finest details of a gear that you see in the inside steel structure of the elements or whatever. The same with the information. You want to know only about the material and the name of the object, or you want to what is the supplier, what is the price, what is the guarantee time, and whatever about the object. So these are the certain requirements, and many of these are present in the EIR or BEP documentation of the BIM documentation. You can check it in a separate BIM module in our MOOC. So, but at the end, we need to capture the geometry of the objects, and we use field to BIM technologies for that. And what are the elements of that? First, we need to know what are the information and data needs. What is the building and facility to be surveyed? What LOD is needed at that survey? What if another survey is needed 2 weeks later with a different LOD? So then you need to consider that one, and maybe you need to use different accuracy, whether there are needed two attributes or not. Whether you need color data, you need the data about the material of the object, about the color of the object. And then if you have this basic information, then you can transfer it to point cloud requirements. What accuracy is needed? Is it needed to be like having 1 millimeter accuracy or 2 millimeters accuracy, or for architectural surveys it's 2 to 3 millimeter accuracy is enough? What point density is needed? What do you want to model from them? How do you want to resample that? What kind of point spacing is needed? What coverage is needed? If we are talking about a power plant, do we need to scan all the pipes from every directions, or we need only the floor or ceiling or walls of a room, and whether we need color or not? And if we have these point cloud requirements, we can transfer it to scanning requirements, and we can select the scanner, what scanner is capable of producing that point cloud, what we just defined, what settings are to be used on the scanner for during the survey, how many scan positions are needed, and where to put that position in the optimal solution, and whether we need direct tie points like using targets, or we use cloud-to-cloud registration. And then if we have this point cloud resulted from these requirements, functional system requirements, then we can start the BIM modeling, building up the geometry, automatically, semi-automatically, or manually. We can use object library or catalog. You don't need to model all the objects one by one. For example, in case of a lamp or whatever, you can select it from a catalog, and you can add attributes. For example, based on the colors, you can decide what kind of pipe is that, what is flowing inside, or you can decide what is the material of the particular object of that structure. You can also decide on the format of the point cloud. For example, in ArchiCAD, we prefer 57 format. You can decide on the resembling. In case of architectural applications, it's usually 5 to 10 millimeters point spacing. And for creating the BIM, the 3D models, there are BIM software like Revit and ArchiCAD, but there are limited size of the point clouds and limited modeling options in them. There are MEP software for the modeling the HVAC systems, but obviously we can use they can manage BIM object catalog and manage attributes. But for specific modeling purposes, if you want to, for example, analyze or correct or manipulate the mesh model, you need to use more sophisticated software environment like MicroStation or Design Bits. And obviously for structural design, for steel structures and reinforced concrete structures, you can use Tekla or Alplan, so different software. So there are different tools. There are scanner vendor software suites that enables, for example, planar the analysis of the point cloud. You can use BIM software, as I mentioned. There are certain BIM software, for example, for infrastructural design, for road and railway design. There is NovaPoint and Quadri, and there are different software, for example, for road and railway construction. One example what we are using at BME is InfraKit. Okay, so to evaluate the scan to BIM technologies, there are multiple available field to BIM technologies. Check the previous modules of the reality capture module. We are dealing with big data, so we need the performance. We need to get prepared for that. For the modeling, the output is depending on the application, so it depends what is needed and what accuracy and what density, and there are multiple software tools available. And I collected some basic references, and thank you for your attention. In the next video, I will just draw the conclusion. Thank you. See you next time.